Thank you. All right, so I hope you can hear me, and because the mic is working, because you are awake. I know this is the worst slot after lunch, but I'm going to try not to make it super heavy. So I don't normally start talks talking about myself, but I guess it's relevant for this one. So as you heard, I'm Victor Tuson. I work at Ivory here in Malaga. I head the engineering team at Ivory. Well, Ivory is a financial sector company, so a fintech. What we do is we do transactional banking. So it's basically foreign exchange, collection of money. Why is that relevant? Because until probably the last 8 months, that's not what I did. So I have always been working in companies that did products for developers, so whether it was Ubuntu or Bitnami or Symbian, so it's always been like focused to developers, right? And recently, obviously, over the last few years, a lot of the products that I was working on, we moved towards cloud native, right? So what does that mean? So for me, I have to say I fell in love with Kubernetes. I love Go. I also love a lot of the kind of thinking behind cloud native principles. And these are kind of some of the things that I like, right? So there are many things. I think we heard over this today and yesterday, different things that are good about cloud native services. For me, the top things were about kind of the ability to decouple the software I was writing from the hardware infrastructure it was running on, right? So that was the first enabler. Then the other thing that I liked, it was like encapsulation on steroids, right? So I was used to be able to encapsulate code and in some cases processes, but this kind of allowed me to encapsulate the execution of those processes and the data behind those processes and build clean interfaces. And as a consequence of all of that, then I had elasticity, right? So I could put it up to the maximum when I need it horizontally, so it's not necessarily time to wait for new machines to come up. But also could turn it down and make sure I wasn't spending too much money when I didn't need to, right? So that was great. Overall, what that meant for me and the teams I was working with was that I could go much faster than I could go before. So that was fantastic. I was in love with that. And then I moved into the financial services, right? But before that, I think kind of we reached a moment which I felt a bit like, Russell Crowe was in my ear. I felt like Gladiator. I had reached Elysium. And then I moved to the financial sector. And there are two things you want to do, really, if you are a financial service company. One is be able to tell people prices about stuff. You want to sell them stuff. And the other one is you want to move money, because at the end of the day, it's financial sector, so money is what we do. There are two main technologies behind that are industry standard. One is the FIX protocol, which is for quoting, and that's used for pretty much everything. We'll cover that in a second. And the other one is the SWIFT network, which, if you ever heard of it, is around moving money around the world. So let's look at some fun facts about these technologies. Right, so the FIX protocol is a point-to-point protocol, which has different variations and different instances and different things. But at large, it's 1992. I'm from Barcelona. That's when we hosted the Olympics. That's kind of some long time ago. I was this high, and now I'm much higher, obviously. It's really built for speed. It does the job really, really well, but it's got its limitations, right? So it's single client per connection. The connection has to stay up as long as you want to be trading and doing quotes, which means you have to have some software acting like a broker for everything behind you to try to get everything through the same TCP connection. You can still request direct lines, so you can get physical wire run to your premises or rented from your premises for speed, but basically it's all about latency, right? So this is great. I mean, I think the bit that I really like is it's an open source standard. So it's an open standard that has open source implementation. So the standard says if it's open, everybody can read. It's not proprietary. Everybody can read and use it for free. And there are open source implementation that has implementations in many different languages. We use in Python, but that's just because it's our stack. But you have it in Go. You have it in a whole bunch of different languages. So that's great, right? So it's not all bad about kind of 1992 technology. Swift, on the other hand, I just love the fact that you have a logo that is old, that is cool again. So the Swift network was set up in 1973, and we are a member of the Swift network. So we are part of the 11,000 entities that move money around the world for 204 countries. So basically, we can execute orders direct to banks. So as you can imagine, that's great if you are in fintech. It's also a bit dangerous, right? Because anybody that can do that can move a lot of money and debit a lot of money from different accounts. You normally have banks, financial institutions. You have to be regulated, obviously, to have access to this. The interesting thing is that it's really basically, or there's a couple of implementations, not all differ too much from this. But our implementation that we use is 3 boxes, physical boxes in data centers running Windows. Where we do is to execute payments, we SFTP orders using the empty format. And the empty format is basically magic numbers. That's what it is. So I don't have any other way to describe it. It's like number 20 means something, number 52 means something else. And you know that's the bank account you want to send money, so you have to put it there. But all is not lost. You know, there's a new version coming in 2021, really cutting-edge technology called XML, that it's going to improve the readability of these messages, right? So you would be thinking right now, this is what our container infrastructure looks like. And you could be right in some cases. But in our case, it isn't, right? So what we aim to do is to have the cake and eat it too. And what I wanted to share with you today is a bit of how do we do that, right? Some patterns to still have cloud-native principles where you can, and not stop some technologies that are really good and really adopted, but do not comply to those standards, right? So the first thing is containerize all the things. So keep containerizing. So I talked about fixed protocol implementation. Obviously, that is a software project that exists. You could run it on an EC2 instance or something. We chose to containerize it because I think containerizing software is still a lot of benefits beyond just being able to be elastic, right? And there's some of the things that we get out of it, right? So some of them are about package management and source management. But there's also about testability and be able to reproduce the environment in a developer environment or a test environment. And there is also the fact that a lot of this technology still has to be tied to hardware, but it can be loosely tied to hardware in a container infrastructure. So something like Kubernetes, you can use Tains, you can use anti-affinity or affinity to make sure things fall in the right hardware pools, but you still get high availability of availability zones because you can vacate from one node that goes down to another one with a small downtime, and it's much, much faster than having to find new hardware or like switch manually and so on, right? So there's still plenty of advantages there. The other one is a pattern that is, these 2 patterns, adapters and ambassadors, kind of coined, I guess, by Brendan Burns in terms of containers. And I think it does apply not just to containers, but also to services, right? So the first one is where you have something that adapts your software to a newer way of running things, right? So a good example of this would be, I mentioned the QFX project. So you could run that in a container, and in the same pod, you could run another one that will read the logs, will collect the statistics, and create a Prometheus endpoint that you could hook it to your monitoring, right? Another one is, OK, we do have some Windows physical machines in data centers, but we build an SQS consumer in front that reads from an SQS queue, and then it's able to load balance the request between those 2, and then the rest of the system sort of doesn't know that that's 6. They think there is just a consumer at the other end, right? But the next one is to encapsulate. So what do I mean by that? So in this case specifically, I'm talking about an example, but you can use it about anything else. I'll talk about these empty files, which is what you can barely see in the right-hand side. But just to give you an idea, it's not very pretty, it's not very readable. It's not the sort of data you want to use for your API contracts, right? But that's OK. So what we've done is we don't do that. We use JSON to pass all the data that we need across our services with defined endpoints and defined contracts for those. And then we have a third-party software that we run internally as a service That is an REST API that you send in that JSON, and it renders the empty files that you want, and that goes into the Swift boxes through that message queue. And you don't have to, excuse me, you don't have to spread these quirks that maybe come from these sort of different standards across the whole system, right? You can stay with the one you like, with YAML, JSON, whatever it is for define your data, and just transform it at the end point where you really need to use it. Right. Obviously, this is not new or specific to this, but what we found is that asynchronicity, especially through message brokers, helps a lot. There are different reasons you will use asynchronicity. If you were here for the microservices chat before, so the speaker before that covered a lot of those. One thing which is specific to what we do is that this infrastructure does need, you probably heard about pets and cattle. This is not pets and cattle. These guys are like family members, right? So this is one step beyond that. And they do need maintenance, and they need takedown, and they need handover. So I think these sort of message queues, message brokers, that give us the ability to hide from the rest of the system different downtimes or very long process times, right? In some cases, some of these processes can take up to 5 minutes, depends on the size of the queues and so on, right? I think it's also important to remember this size your queues correctly and make sure you kind of take that process into account, right? Because at random queues, you have an influx of things that take a long time. Your system will look like stopped, right? So we have different queues taking that into account. And obviously, async REST is also OK. Basically, what we do is once you have a request being processed asynchronous for one or the other one, then we just notify the dispatcher of that request through standard methods, either PubSub or a callback or a webhook or whatever it is. All right, so at the end of the day, what we're trying to say here is we don't live in a bubble, right? You can still make it look like it's floating and it's nice and peaceful, right? So remember to kind of focus on those three things, at least from my point of view. What I learned at Tibur is kind of encapsulation, adapt the different technologies you work into the way you want to work on the system, so that sort of weirdness or quirks don't express to the system. And then finally, decouple, right? So, I mean, we talked about that before, but really in this case it's more important because it's not just about failures, it can be also about the speed of processing, that it's also an impact, right? You don't want necessarily something not necessarily has gone down, but maybe it's taking the time it takes to process is much longer than what you expect right now from different kind of more cloud-native applications. So I'll give you an example of quoting system that we have with Barclays. It takes 1 minute to time out, so you do have to wait a minute to see if there's no one there that is going to offer you a price, or if that takes too long. We manage that with Barclays, but I always said to the user after 15 seconds, we say, yeah, you didn't get a quote, right? So that we separate that through a PubSub queue for notification. So, and that's it, really. OK. Try to go quick, so I know they're like tight with time.
OK. 1 second, because there are still people writing. Yeah. First question is, where do you see the adoption of ISO 2022 in this place? And do you see it push Swift to the side?
No. So I don't think. So obviously, Swift is also adapting to different technologies, right? But as I mentioned before, it's like 11,000 entities connected to Swift, right? Over 200 countries. I think it's easy to think sometimes that, well, I mean, new entities may just jump to that, but like all entities that are massive banks, they're not necessarily the fastest to move, right? So I think anything in terms of banking backbone network is quite slow. As I mentioned, like a lot of these protocols, I mean, Swift has been around longer than I have in life in general. So I think, yeah, of course, over time it's going to be displaced, but I wouldn't expect anyone to put Swift to bed in our foreseeable future.
Second question is there any future for non-card-based systems in financial transactions processing?
Non-card?
Non-card-based systems in financial transactions processing.
Yeah, I mean, this is not card-based. This is account-based, but obviously there is. So one of the things I haven't talked about this is there is a lot of new payment systems that are coming up, which we also support, right? So Europe introduced SEPA as a payment processing system. The UK has a specific FPS stuff, but even Swift, you're looking at transactions that happen within seconds from origin to destination, sometimes across countries. So I guess from the background banking, in terms of point of sales and retail, I think kind of, I don't know, I haven't really used a card for a long time in terms of contactless. You can use your phone and stuff like that. The concept of having a number associated to you is always going to be there, obviously, because we like that. But I don't know if that was where the question was going to.
Yeah, that was a perfect answer. And the last question is, any word on tokenization with respect to financial transactions?
Not sure what you mean by that.
It's from the audience, so any word on tokenization with respect to financial transactions? I don't know if...
Any word could be cow.
Someone wants
to kind of...
raise a hand.
Raise a hand. What do you mean by tokenization in this context?
Good afternoon.
Hey.
What I mean by tokenization is you're trying to avoid re-entering your PINs every time you go to authenticate your transactions over the web or a third-party interface.
Oh, okay. So you're talking more about security in terms of those payments? Yeah. I mean, there are, so I mean, I think, there's a lot of payment solutions that are coming up that are not necessarily related to that. So kind of a bit more of like a last pass for cars. The problem there is there's a quite established industry, right? And getting a standard through that, it's hard because also the existing players have a big influence. I mean, I don't know. I don't know if you live in Spain, but in Spain there is a system similar to that called Bizum, which allows you to send money, and also you can use it to pay on websites, which does not require that. It's based on your mobile phone, and that I think it's only been possible because basically it's a consortium of around I don't know if it was 40 bank entities in Spain or something like that. So really, it needs for the industry players to come together and say, yeah, that's going to be a standard, right? I think anything else, yes, you're going to find some niche players there. I'm sure that with companies like Stripe and so on becoming the back end to payments on the web, they will have more leverage to introduce some of that, but you're not going to see anything which is across the board as much as cards and PINs until that happens, right? At least from my point of view.
I have a new question as well. Does SEPA currently uses Swift, or it is a separate network?
It's a separate network. It's a European-based delivery network, so it's doesn't go through Swift. It has the same concepts of payment messages and so on, but it's a separate one.
Okay. Any other question? Someone raises the hand. No. So thank you so much.
All right.
Please,
thank you.
Can make applause.